Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to do the exercise for association. Me, Mr. Fares, Hamid, and Mr. Loai Al-Qadasi. We are semester 2 software engineering students. So we decided to work together and build this exercise for days, and we come up with this simple exercise, and with some explanation. I will construct Loai, and he will write the code as a constructor, navigator, and driver. And we will starting by reading the overview of the exercise. Loai, if you want to read the exercise from the top to bottom is okay, but for now I will read it. Is it okay with you?
Yeah, it's okay. You can go for it. You can start from the iStream, or you can start from up there.
Okay, no problem. We say Bismillah, and we go now. Okay. So now we start with the IO stream. We start with the library CMath, and yes. Can you now? I will tell Loai now to include another library, vector library. Please, Loai.
Vector library to store the
Yeah.
to store the values, right?
Yes, for multiple terms for the polynomial.
Okay.
Thank you, Loai.
So we have like x and other y, like other x's.
Exactly.
The binomials, like the x and the other x's, like for the evaluation.
Yes, that's true. Loai has got a point. The x now will be stored in the vector, as it will store all the terms. What terms for it? Okay, we'll continue right now because we built the program and we forget a little bit, but we will continue, and the program will inshallah will print the terms, will print everything. So now we will continue by starting with part 1, first part. Loai, if you want, I will just explain and describe the first part.
Okay, you can explain the first part, so go ahead.
So the part 1 is term class declaration and implementation. So explanation for part 1. This section focuses on the term class, which is a fundamental building block of the polynomial. The term class models a single term of a polynomial, such as 5x to the power of 2, or exponent 2, or minus 3x. It has two private attributes. One is the coefficient, represent the numerical factor of the term, such as 5 in 5x to the power of 2. So second part which is the exponent, represent the power of the variable x, such as 2 in 5x to the power of 2. So 2 is the exponent. The third part, Loai will read it.
So let's go briefly to the first point. So we have the coefficient in like 5x minus 5x to the power of 2. So the 5 over here is the 5 over here is basically the what? The coefficient, and the 2 over there is the exponent, right?
Yes, thank you, Loai. It's very good. Yes, the exponent and the coefficient. You can.
Should I go with the finish from here?
If you want to go, you go. But if you don't mind, I will continue reading a little bit for this, so we can start in very good way. Is it okay, Mr. Loai?
Yeah, before starting with the class, no, before starting with the class, should we just finish this so we can go ahead?
I agree. I agree.
Writing
Yeah.
the
Yes, yes. Writing the names and everything. Yes, 2024, 2025, and the matric numbers.
section 2.
Section, yes, section 2. The name. Okay.
Uh,
So take your time.
Fares,
Take your time.
Fares like this, right?
Yes, Fares Hamid.
Hamid like this.
No, no. ID. ID.
ID like this.
Yes. Fares Hamid Abdu
Abdul.
Mohammed. MO Mohammed. Yeah. نعم هذا صحيح. صحيح. This is very good.
Location, we do like Google. It's basically Google Meet. Google Meet. Okay. For me, my name is Loai Al-Qadasi. Location, same meeting. Same online meeting. So times we started 9. Particularly we started at the 17. Well, today is 17 of 12 20 24. The time was started at 9:10, right?
Yes.
It's like 10. 2 we're gonna just justify later, and also for the duration.
Yes.
We're gonna just end this. The video link will be later.
Yeah, yeah.
So
now
you can
we can just
finish
go to the part 1 straight. So now
Yes.
we will just start like class term, right? Class term. We have the private, coefficient, and exponent. We have the public, we have the term, int c equal to 0, int e equal to 0. And outside of this, you can start by writing 2 points, and you take the semicolon, take it or delete it. Yes.
Okay.
And coef, coef,
COF, like sorry, it's capital letters.
Yes.
COF.
C between braces.
Between braces. Like we should let it accept the parameter, right?
Yes, yes, accepting parameters. And here, yes, this is the constructor and exponent e. And the same exponent e. And comma.
Is it comma and like this comma, and we let the other one like exb, right?
Exactly.
Xb except the parameter of e.
Yes, exactly. And yes, outside you write curly braces.
Curly braces to start.
Yes, and you leave it like that without semicolon.
And I leave it like this without any semicolons.
Yes, this is the constructor right now. So this is the constructor, and it has like the value of 0 for E and C. So now after this we have the void, which is set the coefficient and exponent for the term.
So you have to do sitters right now, right?
Exactly. So int C, int E, and after the set int E and int C, outside of this you delete the semicolon, you put curly braces, and coefficient equal to C, coef equal to C, and equal to exponent equal to e.
So for this, I will do like
The two
this
private,
one
yes, two private values equal to c and
equal
e.
c, and the exponent equal to b, right?
To e, yes.
The exponent is equaling. We set the coefficient for c, and we set the exponent for e.
Exactly.
All right. Next.
The next get a coefficient of the term. So int cof.
So it is
So
getter now.
Actually, let me just take evaluation. So yes, we can start with the evaluation. So by const, there is a const outside. So you delete the semicolon at the end.
I delete the semicolon at the end of this one. Okay.
Yes, and you put curly braces. And yes, enter. And inside of this, you write return.
Return.
The private cof.
Return what? The private. You mean like
coefficient?
C
Yes.
or
Yeah.
E F?
Yeah.
Like this one?
Yeah. Multiplied by POW. Multiplied by.
Multiplied by like this one.
Yeah.
B.
POW. The math function.
This is the use of the C math header, right?
Yeah, and the braces. And inside of this x comma exponent, the private one. Exactly. And outside of this there is semicolon. Yes.
Semicolon.
Thank you. The next one, which is the exponent.
The exponent. Okay.
And the same for the exponent.
What I set inside the exponent?
Return exponent and semicolon.
Return exp, right?
Yes, and semicolon. And for the coefficient, the same.
I delete the
exactly, yeah.
And curly braces. Inside this, I will write what inside the coefficient?
Return cof.
Return C O E F. Like this.
Yes, thank you, Loai.
All right.
So let me just now explain more about this part and check my frames. There's just.
You still have like 2 minutes to finish the first quarter. The first 15 minutes. You still have like exactly 2 minutes.
Yes, I hope inshallah I captured everything, and also the voice I capture it, and I hope there is nothing. Yes, we have 2 minutes right now before we finish the first part, so I will explain a little bit more. Thank you, Loai. I will continue right now. The set method is used to update the coefficient and exponent of the term. There are getters method, coefficients and exponent, which retrieve the coefficient and exponent respectively. The evaluate method, so the evaluate that we have written already, calculates the value of the term for a given value of x. For example, for the term 5x to the power of 2 and x equal to 2, it calculates 5 multiplied by 2 to the exponent of 2, exponent 2, sorry, equal to 20. This class is essential because it encapsulates the behavior of a single term, which is later used to construct the entire polynomial. So this class is gonna construct the entire polynomial, so that's why it's very important. And by finishing this part, we just completing the polynomial itself, but we need the other classes, so we keep sorry, for the term, after the term we go to the polynomial. After the polynomial, so we go to the to explaining the evaluation function, so the degree function, and by lastly we go to main function. And we now just gonna wait a little bit to finish this part, and thanks for now we
Okay,
will
so
continue later.
for the
Yes.
first class called term, we just set this class only for the term itself that the user gonna enter for us. So we're gonna take the term in the evaluate getters in the evaluate one, and the evaluate one will just multiply it with the exponents. We'll just give it the power of the term that he gonna enter. Like for example, if he gonna enter the exponent, the first term, which is x, and to the power of let's say for example it's 3. So this is evaluate. So give us a coefficient times for like a coefficient, which is the number before the x, which is for example 2. The coefficient 2 multiplies by the what, the term he enters to the power he will give us as an input. So that's for the first class term, just for to set the what, the this one, the
Yeah,
most
thank
important.
you. Thank you, Loai. So now we
And was
will. Yes, yes. We'll continue in a few minutes. See you later. يلا بدينا.
اوكي بدأت الموقع كان.
يلا يلا.
Okay, let's go now with the second class for the day, which is polynomial. Okay, man, I couldn't pronounce it.
Polynomial.
Polynomial. Okay,
It's no
let's
problem. It's no
go.
problem. It's a little bit difficult to to speak about. So it's polynomial. It's mathematical.
Okay.
You know, mathematical is difficult.
Yeah, it's the polynomial. It's next to the x. No, sorry, the polynomial is the x itself.
Yes, yes. Thank you, Loai, for the little explanation. I will continue.
Mm-hmm.
So polynomial class declaration explanation for part. This is part 2 actually. So this part introduces the polynomial class, which is represent a complete polynomial consisting of multiple terms. The polynomial. So I'll explain about it. Class uses a vector of term objects to store all terms of the polynomial. The vector allows dynamic storage of terms so the user can create polynomials of varying sizes. The constructor initializes the polynomial as an empty collection of terms. The input method collects user inputs to define the polynomial. So now Mr. Loai will continue by writing the part 2. Bismillah.
So for the private, the vector one, what should be taken into because it's
Yes.
all empty.
You start by writing vector terms between bigger than, less than.
Okay, like this one.
Yes.
Then
Term.
I write term. Okay.
Yes. And term outside. Terms.
Terms. Okay. This is the way we declare the terms. Okay.
Semicolon.
Semicolon.
Exactly. Now in the public. Polynomial, we should write the curly braces outside of the polynomial.
So it's
before the semicolon.
It's only like declared as a constructor, right?
Exactly. Because it's actually a constructor. Polynomial is a constructor in class polynomial.
Yeah, because it's the same name of the class.
Exactly.
Okay.
So in void input, we write so we put curly braces and we put inside of it
all right.
Yes, in Yes, n and the semicolon.
The n is number of what?
N is the number of terms.
Okay.
And
Then
in C out, yeah, you're right, C out.
should I display for him?
Yes, enter the number of terms.
Enter the number of terms. Okay, what else?
Okay, can you put 2 points in the enter the number of terms? 2 points and space.
Okay, like this.
Yes, exactly. So this is for the formatting purposes. After this one, you have cin. So we enter the values from the keyboard of the user. And yes, exactly. And also we need a loop for the terms.
What type of loop for?
Sorry, it's not for the terms, it's for the coefficients and the exponents. Loop for and int I equal to 0 between the braces.
I equal 0, okay.
And I less than n.
I is less than n, right.
And semicolon and I plus plus.
I plus plus.
And outside of this we have need curly braces. And in the curly braces you enter int coefficient and exponent, and comma exponent coefficient comma
we start to declare it again because it's a new class, right?
Yes, exactly. And C out enter coefficient and exponent for terms. C out.
Okay, like this. Enter what? Enter the what? The coefficient, right?
Coefficient and exponent.
And exponent.
4 terms.
4 terms.
And you have you write dash. Yes. Right. And yeah, that's it. And outside of this you write less than twice. Yes. And between braces there's I plus 1.
I plus 1, like this.
Yes, exactly. So we have the count in the loop. So outside of this you write yes, and between 2 quotes just 2 points.
Like this.
Yeah, and space.
And space here.
Yes, exactly. And there is semicolon outside. Exactly. And let me check just the time.
The time we still have 8 minutes to speak. 8 minutes and a half.
Yes, we have enough time. So now terms. You write terms.
I write CN.
Yeah, CN. Yeah, CN to enter the keyboard words. Coefficient, also exponent.
Also like this.
Yes,
exponent. Okay.
Yeah, exactly. And semicolon and all enter terms.
I write the word terms, huh?
Yes, exactly.
Okay.
And dot push back.
Push back the first one that appears to me, okay?
Exactly. You press this. And between braces, you write term.
Term like this in capital,
yeah,
okay?
And yeah, and braces also.
Braces also. Coefficient.
Comma
right.
exp.
Comma exp, okay?
And outside you have the semicolon.
Like this.
Yes, and don't forget the curly braces outside of the loop.
Like this. This is for the end of the loop, okay? And
exactly.
I need another one to end the input. Look, the input has no.
Yes. Yes. After the loop, exactly. You need the. Yeah, exactly. Now we outside the loop, and we outside the input also.
All right.
So the let me explain the other uh, parts little bit, so
Mhm.
we can have enough time to finish part 2 and we can explain everything. We don't miss anything. Is better than missing some stuff.
Okay, you still have like 5 minutes. Let me just check something. It's showing for you now the code or not showing the code?
Yeah, now it's not showing the code.
It's not showing the code at all. So Control D, Control D. Okay, how to show the code?
uh, use the code right now. It asks the user. So I'll explain a little bit. The input method collects user inputs. That's the input. If we go down here, we have void input. So what's void input is? It collects user inputs to define the polynomial. It asks the user for the number of terms in the polynomial. For each term, the user provides the coefficient and exponent, which are stored in the vector in term object. This class provides the foundation for multiplying manipulating polynomials, such as evaluating their values or finding their degrees. So in what is vector terms? This vector to store terms of the polynomial. So that's simply it. In for the number of terms, we will in this part enter the number of terms. We will display the enter the number of terms. The keyboard, we will enter the value of the number of terms. We will enter like 1, and then we will go to the loop. If the user enter number 5, so it will let the user go to the loop 5 times. He will enter the coefficient and the exponent 5 times. He will give, or he will take the displayed text, enter coefficient and exponent of for terms 5 times, and will after the dash we have I plus 1, which means that I was 0, so plus 1 is going to be 1. So the first one is going to be after the dash is 1. The first one is like 2 and 2, the first exponent out of 5, out of 5 terms. The first term, the coefficient and exponent. The second term, the coefficient and exponent. The third term, the coefficient and exponent. So we put all the values. So now we will calculate it. We'll get the value of x0, 2, 0, 1, 2, 3, 4. So it is 2. Well, so 2 to the exponent of 2 multiplied by 2 plus 2 to the power of 2 multiplied by 2 plus 2 to the power of 2 multiplied by 2. So like this, and also if x is 0, if x is 1, if x anything, so uh, it's still having the same. So it's very simple. This part is very simple. It's not very difficult. It's just we're talking about the class polynomial, the first part of it, which is the private vector terms with the public polynomial. We make it as a constructor. We make it empty constructor, doesn't have anything. Void input, we int integer n for the number of terms, and is very simple like that. And we will wait a little bit for 2 minutes now to finish this part. If Loai has anything to say, he can just say it right now.
For me, I think that you have explained everything briefly about the polynomial class. I don't understand anything for the private that we use vector to store in the term itself, and we use it to push back the coefficient and the exponent itself. So for the terms, it's the same. We ask the user to enter a number, and that number we take it into a loop after that. If we to display here the number that he already entered, and ask him again to enter the coefficient, here the coefficient and the exponent coefficient, then he do like a space, then again add the exponent. Should we just add here like explanation, like see out, do a space, or no need for that?
If you want to explain. Take your time.
I'll do like to explain to him, like enter like space between them, between the exponent and the sorry, between the coefficient and the what, and the this one, like for him to understand between the
term and the exponent and coefficient.
And coefficient, okay.
And now
for him, please, like this, and I give him example like the example, like for what, like 2 and 4. This is the 2 is the coefficient and 4 is the exponent.
That's true. That's very true. It's a correct way. Like that's what the user who will open the program will see. He will start writing 2 and 4. 4 is going to be the exponent, 2 is going to be the coefficient, and it's going to go into the loop. If you enter the term 5, it's going to go 5 times. You have to enter 2 4 2 4 2 4, like 5 times is going to be 5 multiplied by 2 is going to be 10 times. You will enter 10 values in the coefficient and exponent parts. So now we will finish. We'll stop a little bit and we'll continue. Thank you, Loai.
All right.
Assalamu alaikum. We will continue right now with part 3. As we said, we divided the code into 4 parts. So we make it simple and explainable and describable and manageable and deliverable.
All right.
So I will explain this part 3, right?
Yeah, we are in part 3. No, yeah, part 3, which is here.
Yes. Yes, part 3, I'll explain it. So it is polynomial methods. So explanation for part 3. This section provides methods for analyzing and evaluating the polynomial. The evaluate method calculate the value of the polynomial for a given x. The first thing, it loops through each term in the polynomial. Second, it evaluates the term for the given x and adds the result to a running total. Third, for example, for the polynomial 5x to the power of 2 minus 3x plus 7 and x equal to 2. It computes 5 2 to the power of 2 minus 3 2 plus 7 equal to 20 minus it's gonna equal to 20 minus 6 plus 7, so it's gonna equal to 21. The degree method determines the highest power of x in the polynomial. So now we continue the fun by writing the code with Mr. Loai. Bismillah.
All right.
So we will start with evaluate function.
Yeah, I'm just trying to explain what you just said right
Okay.
now.
It's gonna be very good if you explain
Like
previously.
this.
Is very good.
So let's show that the x. All right. Let me just x is equal to 2. So it will be 5 times 2, which is 10 to the power of sorry 2 to the power of 2 is, which is 4.
Yes.
4 times 5 is 20. So minus 3 times 2 will be 6. 6 minus 20, that's 20 minus 6, that's 12, right? 12 plus 7, you said how much?
12 plus 7 is gonna be 19. But let me just check.
No,
Uh,
it's be
it's gonna be
12
21.
minus
12 minus 6 plus 7 is gonna be 21. 20 minus 6 plus 7 is gonna be 21. Yes.
Alright, so it will be 21, right? Sorry, 21. So the evaluate, what should we do here? Open like this one?
In the evaluate part, after the const, you delete, yes, yeah, you delete the semicolon. You make the curly braces, and inside of this, you start by integer sum equal to 0.
Start with int,
Yes.
int, int sum. We declare the sum and we set it to 0, okay?
Yes, exactly.
Semicolon after this?
Yeah, semicolon, and
Mm-hmm.
enter,
Mm-hmm.
and the loop for.
Mm-hmm.
Between the braces, you write const auto.
Cons what?
Auto. AUTO.
Auto, like this.
Yes, and the and sign.
Reference sign, okay?
Yeah, reference sign and term.
Term or terms with the capital or small?
No, it's with the small. Yes, this is correct. And
Okay.
two points and terms and also small.
Terms small, like
Yeah,
this,
yeah.
okay?
This is correct. Now outside of this, there is a curly braces and enter. And inside of the curly braces, sum plus or equal.
Some plus equal like this, okay?
Yes, term dot evaluate x.
Dot
Evaluate.
evaluate
Between braces
between
x
braces x, like
and
this.
semicolon outside.
Like this.
Yes, very correct. Now you can go outside, or I will explain this part a little bit. So the term, so sum plus equal term dot evaluate x, add the value of each term to the sum. So that's the this part, and that's what it means. It adds the value of each term to the sum. So we're gonna have one sum.
All right.
So outside of the loop, you can enter.
Yeah.
When you enter, you can write return sum.
Return, and we do CSUM like this.
Exactly. So now add the value of each term to the sum. So we will have, after we getting out of the loop, we will go to the sum and we will return the sum.
All right.
So enter, also enter again.
Like this.
Yes, exactly. Can you go to the degree and miss the term for a bit?
I skip this and I go to the degree directly, okay?
Yes, no bro, no issues.
All right. So I delete the this one. I do this one, okay? What's next?
No issues. Let me just check something about the time.
We still have 8 minutes and 20 seconds.
Okay. So what do you think? Do we need the term largest term?
You mean the highest exponent?
Largest term? I think we don't need this, right? We can just comment it out. Term largest term.
So,
This constructor.
so this constructor, we don't need it. Or should I do like this? Uh,
I think this is a constructor. No, something else.
okay, it's should be like this, no problem. Okay, or should we finish?
Yeah, because it's not usable. Largest term.
Okay, for the nth degree, we keep doing the nth degree.
Yes, we go to the after the evaluate. We go straight to the degree,
All right.
and in the degree we have to inside of the curly braces. You can start by integer max degree.
I do integer,
Integer
and the integer name is
ma-
what?
max degree.
Max
Max degree equal to x.
degree equal to
Zero.
0.
Zero. Sorry.
All right.
Yeah, and enter
Mhm.
for loop
For its loop again. Okay.
and const auto the same.
Const, sorry.
The same as above. Okay.
Const O2, and I do the same above, like the
Yeah,
pointer
exactly. If
with
you
the
want
term, right?
or I think it's better just to write it down, but yeah, the same.
Term, two terms. Okay. And
Yeah, yes, and then curly braces.
with the for loop, okay.
Yes, inside of the curly braces there is if condition. In the if
If
condition, we will write term dot exponent braces bigger than max degree.
exponent, all right, like this.
Yes,
Should I do?
and bigger than max degree.
So it's bigger this one, right?
Yes.
Bigger than max uh, degree.
Yeah, exactly. Max degree equal, and then no, no. In the if condition, you just leave it like that without equal.
It's not equal to the term exponent.
No.
All right.
So
So
outside, yes, there is also curly braces. Another
again,
curly
curly
braces.
braces.
Yeah. Also, already you have right. Yeah, you need curly braces for if condition. It's cool right now. In the if condition,
Right.
term dot exponent bigger than max degree, you write max degree equal to term dot exponent.
So
Max
I do
max no
like start with max
max
degree,
degree.
okay?
Yes, max degree.
Max, sorry, max degree
Equal to
equal
term dot exponent.
term dot exponent. Okay, and then
Braces,
uh-huh.
and outside of this you write the semicolon. So after finishing the if condition, term dot exponent bigger than max degree, which is equal
So
to 0. Now it's bigger than the term dot exponent. What's gonna happen? So we get out of this so we get the return degree, and we return the value of return degree.
return degree is here before the last thing, right? After the
Yes,
if
after, yeah, outside of the for loop.
link, this is the if and this is the for. Let me
Yeah,
check the for.
yeah,
This
outside
is
of
the for.
outside of the for loop. Exactly. Return max degree.
Return max degree, like this.
Yes, thank you, Loai. Correct. So now, how much time left?
We still have 3 minutes and 20 seconds to finish this one.
Okay. So I will explain little bit more about the left of these parts. Okay, the degree. What's the degree? Method. This is a method of the class polynomial. It's not a function, I'm so sorry. But let's continue. Determines the highest power of x in the polynomial. So can you delete term largest term because we don't need it anymore?
I think this is needed to access this one for the term. To access the term, how do you access the term inside the?
Okay, no problem. Leave it as is. Yeah, leave it. We will check later. We will run it and check if it's already needed
Okay,
or no issues.
I will. Sure. Look, when I deleted, they show to us it's no issues found. So let's keep it and see if it's making any difference.
Yeah, no problem. Okay, I will just continue now explaining a little bit. So degree method determines the highest power of x in the polynomial. First part is it iterates through all terms to find the maximum exponent. Hmm. For example, for 5x to the power of 2 minus 3x plus 7, the degree is 2 because the highest exponent is 2. These methods are essential for evaluating and understanding the properties for the polynomial. So, yep, as you can see, I tried to explain this part as much as I could. Now we're gonna wait just to continue the 15 minutes straight.
I will still have like less than 1 minute, so everything is explained. Should I keep this one here or should I delete it? The explanation here.
No, you can leave it. There's no issues. It's better because it keeps us like we record the video. We have the explanations ready in the program. We later we will run the program and send it to the doctor. The doctor will see the explanations. The doctor will think that we did explanations in the video. He can check the video. He can understand that it's explainable. It's simpler than it is.
Alright, I also added this from my side, but it's okay to add this, right? Just for explanation for any user. We're trying to make life easier for the user, you know?
Ah,
Yeah.
yes, I got you.
Alright, so I guess the 15 minutes is already done.
But
We can
can you
come back.
delete the C out? You see the C out enter a space between the coefficient and exponent
Yeah, I
because
just said that we just make this to make the life
yes.
easier. So if I run it now, there's no int main, unfortunately. But if I run it, they will show if. Let me just explain to you.
True is better.
Like this.
Yeah, I got you. I got you. Yeah, you
Enter
don't need.
the
Yeah, yeah.
coefficient. All right. Should we keep it or delete it later? So we will see after doing the int main.
So we will leave it right now as is. If there is some issues, we will fix it. Now we'll stop a little bit, take some time, and come back later. Thank you.
All right.
Assalamu alaikum. We continue now with our fourth part. It's actually all about me. Me and Mr. Loai were writing. I will guide him. Bismillah. I will explain the fourth part briefly. Is it okay, Mr. Loai?
Yeah, you can go ahead.
Do you want to write anything?
You should declare the class. We give it like an object, or
Yes, no issues. You can write the object polynomial. You can write polynomial.
I just do capital letter. It will show like poly and no.
Yeah, you can just tap and poly, Poly,
So should we do it like only B or B capital, B or small,
small,
or
small,
should I name it anything else
poly and semicolon.
like this?
Yes.
This
Uh,
B stands for
uh,
Bobby.
I agree with you. This is easier and this is more understandable for us as programmers, as intermediate programmers. We are not beginners. We are not professionals. But this is very
Okay.
good idea. Yes, is B only. Is okay. Understand. So now let me explain the fourth part briefly before Loai starting writing the code.
All right.
So what's the fourth part is I'm gonna explain it is the main function is where user interaction and program execution occurs. Of course, it begins by creating a polynomial object. So what I have created already is polynomial object, which its value is b, or it's referred to b by to the class, which represents the polynomial to be analyzed. It calls the input method to collect user inputs. So input method to collect the user input, allowing the user to define the polynomial by specifying its terms. So it allows the user to define the polynomial by specifying its terms. So after this, it calls the input method to collect user inputs. So it will call the input method to collect the user input. So when the user starting writing by his keyboard, he will enter the values. So we will collect the values that the user enters and we will use it as the coefficient, the exponent, the terms and everything, and we will get the degree and we will print the runned value, the run value, and we'll see the highest exponent and we'll see the polynomial values. I'll continue. So allowing the user to define the polynomial by specifying its terms. After this, the program then calculates and it displays the degree of the polynomial using the degree method. That's why we use the degree method, is to show the highest exponent value. And finally, it's not finally, but it's before finally, it evaluates the polynomial for x equal to 0 to 5 and prints the result in a tabular format. So what does this mean? I'll read it again. It evaluates the polynomial for x equal to 0 to 5. So when we go to the loop from x equal to 0, so we go to x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5 until x equal to 1 and prints the result. We will print the result of the coefficient and the exponent and in the tabular format, in the table. So in the table, when we print, there is a format, it's going to be printed as in that table. So I will not go through everything before I start writing, so we can understand much better. So
Yes.
Mr. Loai is gonna start by going through the cout enter a polynomial.
So we ask the user now to
Yes.
enter the data that we want. We start to tell him that he should enter polynomial
You can write a polynomial.
All right, enter polynomial like this, right?
Exactly, and 2 points.
Mm-hmm.
And this, there is no space actually. You don't need to. So and then there is less than twice before idle. and yes, for the so we access the input. So we need to poly, so p dot input.
B dot degree or evaluate or input.
Input. So we access the input. So yes,
Okay.
yeah, it's very good. Now this to get user inputs for the polynomial. Why we put this, Mr. Loy?
It's calling the function inside the class above. We call it using the object that we give it to be.
Yes, we
and
call the method
inputs,
for this
we
part.
store it inside.
True. Yeah, Loai understand this. Is Loai just is not just writing. He understand this part correctly. We build it together. Thank you, Mr. Loai. Now we will continue. Get user input for the polynomial. We finish this part. So print the degree of the polynomial.
So we want to get also another input, which is the what?
Exactly.
The degree.
Yes.
Enter what? I ask him to enter a degree.
The degree of the polynomial is no. We can just. I think we can just print the degree. Yes. See out. You can. The degree of the polynomial is.
I write the what? The degree.
Degree of the polynomial.
Not the no. يلا this.
Yes. L exactly is. And space after the 2 points.
Okay.
And there is less than twice after this. P dot degree.
So there's what b dot we call the degree now, huh?
Yes, exactly. And that's correct. Yes, yeah, I forget about this, but now we put it correct. Now yes, we can you make space? Yes, a space after this one.
Should I made what?
Space yes,
after what one?
Yeah, enter
like this.
Yeah, exactly. Now it's like more easier to be seen. Now so there is already polynomial value already here. Can you change can you put like a new line before x?
Can I put a new line after x? Where's the x?
You see polynomial value.
The polynomial value, this one, enter polynomial.
No. There is a C out polynomial value. You see this? Yes.
Yeah.
Go back before x and make like under dash, or I don't know what they call it.
Backslash n.
Yeah, backslash n.
You mean like this?
Yeah, and space, little space.
All right.
Exactly. And tt already there is 2 t's. And indel, and after this one there is already over here it's indel. So this is all about formatting. Can you make the n? Can you take the space before n?
Can I take the space?
There is a little space before n, backslash n.
Backslash n, no need for the space, huh?
Yes, the space. Yeah, exactly. So now is very correct. Can you make space after the tt, the cout tt?
Can I make space before the cout tt, huh? Where should I make it?
After the here. No. After the cout tt. No, I mean after the endel, after everything.
After the endel here?
Yes. Yeah, space. Exactly. Now it's very correct.
What should I add here, or should we keep it for later?
So in this part, let me just check. I remember. So there is a loop in this part, so you can delete this. You can just delete it.
4. We have the loop of the 4, and we have the cout for the x.
In the loop. Let me just explain what we will put in the loop. So we have in the loop for integer x equal to 0, x less than or equal to 5, and x plus and inside of the curly braces, can you make curly braces between this loop? Yes, and it covers the C out.
Yeah, covers the C out. This C out or this C out?
No, the first C out only.
This one until
Yeah,
here, right?
yeah, until here. Yeah, exactly. Now inside this C out, we're gonna change some part of the C out. There's a
This
space. Yeah, there's a space after the C out. Can you make a little space, context space?
like here space.
Yes, exactly. And after the X, there is two T's. After the two T's, there is like less than P dot evaluate X.
Like B.
P dot evaluate.
Should I take the evaluate one?
Exactly, X between the braces.
Okay.
X inside of the evaluate.
X. We take the parameter X.
Yes.
Expect me to enter a parameter. Let me check what he wants. He wants
X.
a parameter, so I give him X.
That's correct. Now I think we can just run the program, but can you delete the C out in the last?
But we add here the B evaluate. But have we declared the evaluate one?
What do you mean?
I mean, for the evaluate, we did create it, right? But for this one, should we run it or should we add things here? Should I delete this one?
Yes, yes, please. Can you delete this one? Yes. Now I think you can run it and there's no issues, inshallah.
So there's like 3 minutes.
No issues, but if you run it,
Alright, I'll run it now. Function term in 1, 2, 3. 1, 2, 3. Is there any need for this one? Should I think we did already this one up here. This one is already declared. Why should we declare it down there? Should we just delete it? This one is the same thing as the issue showing here.
Let me check. Let me check. This one is over here. This one is over here. Yes, you can delete one of them.
I'll delete this one.
Yes. Now you try to run it. Inshallah is running. There is no issues.
Alright.
Yes. Now
number of terms.
Now we'll make it like the program. We'll check the exercise and we'll make it as the exercise is asked. So give me a second. Give me a second. So can you enter in the terms? Can you enter one?
One, okay.
And in the coefficient and exponent, enter 3 space 2.
3 space 2, like this.
Yes. Can I see the values?
Till 5, we have 3, 12, 27, 48, and 75.
Yes, and the degree of the polynomial is 2. I'll check the exercise. So the degree of the polynomial is 2. That's correct. And the highest value in the polynomial values is 75, 3, 12, 27, 48, and the x is all correct. There is everything is almost correct. There is no issues, and I think we finished in this part. I think there is nothing to say. If Loai has anything to say, he can just say it.
For me, I have nothing to say. I think we have done amazing for today, and everything is correct and accurate. Everything is good.
Thank you, Loai. Shukran lak. Alhamdulillah, we finish exercise 4. So now we can just download it to the YouTube, inshallah, and see you next time.
All right. Thank you very much.
Assalamu alaikum.